Okay, so we're going to be going over circles, the circles chapter 31 in my book, Overcoming Digital SAT Math. Now, before we even get started, I'm just going to preface this by saying, I know at some point I'm going to say like arc measure when I mean arc length, or arc length when I mean arc measure. So I'm going to just preface with the explanation of the difference between the two. That way, if I accidentally slip up, which I'm going to try very hard not to, but for some reason it always happens, that you guys understand what I mean. So here I've drawn an example circle. So right here we have the inscribed angle is 30 degrees, the central angle is 60 degrees, and this highlighted portion would be like the arc I'm talking about when I say arc measure or arc length. So there's two ways that we could talk about that. We could say arc measure, and the arc measure there would be in degrees, which would be 60 degrees, because you're talking about the measure of the arc in reference to the central angle. So there, you would say the arc measure is equal to the degrees of the central angle, which is 60 degrees. Or we could talk about that portion of the circle, this arc, in terms of arc length, which is not in degrees. So like, you're usually going to see a pi with that, because what we do with arc length is we think in terms of the circumference, and then we say how much of the circumference are we talking about. So like the circumference is equal to 2 pi r. That's why I wrote 2 pi r here, 2 pi times the radius. Circumference is kind of like the perimeter of a circle. Like it's how long it is all the way around. Now, if we're talking about an arc, we're only talking about a certain portion of that circle. We're talking about just that part, not the whole thing, right? So if we multiply by what fraction of the circle that arc represents, and we multiply that times the entire circumference, we can get the length of just that arc. So here we're talking about a whole circle is 360 degrees, and this arc is corresponding to only 60 degrees of the circle. So 60 over 360 would simplify to 1/6. So we're talking about only 1/6 of the circle right here. So we would just say, okay, I'm going to take 1/6 of the circumference, and that would give you arc length. So typically, and the reason why I mess this up so much is because it's like referring to the same part. It's just I always like mix up what word I'm saying if I'm talking too fast or something. But essentially a shortcut is to say arc measure is in degrees. So like if you're looking for degrees as your answer, it's arc measure. If it's not in degrees and it has like a pi in it, then that's going to be arc length typically. So that's kind of like a little shortcut. But you have to be careful with that also, because you can also have degrees in like radians, which has pi in it. So like it's like a little shortcut that is helpful as long as you're paying close attention to what you're working with. But if you want like the actual definition, like arc measure is going to be based off of like it's equal to whatever the central angle is of the circle, and arc length is just like the portion of the circumference, like the length right here. Okay, so now that that's out of the way, let's get started. So pause to read number 1 if you haven't already. Okay, my drawing skills are subpar at best, so we're going to pretend that that is a perfectly inscribed circle in the square. So yeah. So basically, this scribbled or shaded portion is what we're trying to find the area of in this situation. So to do that, we have to find the area of the square and then subtract out the area we don't want, which is the area of the circle, right? So area of the square is easy. It's just 10 times 10. So that would be 100. And then now we need to subtract the area of the circle. So area is equal to pi times the radius squared for the circle. Now we know that the radius is 5 because the circle is inscribed in that square. So the radius is going to be half of the diameter, which is equal to also the side length right there. So diameter would be 10, and then half of that gives you the radius 5. So now all we need to do is subtract out pi r squared, the area of the circle, and plug in 5 for our radius. So this is what you get. So now 5 squared is 25, so you have 100 minus 25 pi. So the answer is C. Okay, pause to read number 2 if you haven't already. So we want to know the arc length is what fraction of the circumference of the circle. So basically, like, what fraction of the overall circumference is this portion right here? Now, we have an inscribed angle right here. So we also know that the inscribed angle is going to be half the central angle, and that the central angle is equal to the arc measure. So that means that if this is half the central angle, our central angle needs to be double that, which is 80. And that's equal to our arc measure. So we're talking about 80 degrees out of the total degrees in a circle, which is 360. So we have 80 over 360 that we're talking about. We can cancel out the zeros, and then we could divide by 4 on top and bottom to simplify the fraction. And when we do that, we get 2/9 as our answer. Okay, so pause to read number 3 if you haven't already. So we're trying to find the measure of that highlighted angle right there. So let's consider how much of the circle we're talking about. The area of the entire circle is equal to pi times the radius squared, right? But they tell us that the area of that shaded or scribbled region is 18 pi. So we're talking about 18 pi as our part over the whole area of the circle. So this is what that would look like in a fraction format. We can cancel out the pi's and plug in 8 for the radius. And then if we continue by squaring the 8, we get this, 18 over 64. And then you could divide by 2 on the top and the bottom to simplify, and you get 9 over 32. So that's the fractional part that we're talking about out of the entire circle. So if we want to know what the measure of that central angle is, we could say we're talking about 9 out of 32 times the total degrees in that circle in radians, but in radians instead of degrees. So instead of saying like times 360 degrees, we would say what that is in radians, which would be 2 pi. So we would say 9 over 32 times 2 pi. And now I can cross cancel because 2 goes into 2 one time and it goes into 32 16 times. So then I have 9 pi over 16, which is B. Okay, pause read number 4 if you haven't already. So remember, this is the equation for a circle where h comma k is the coordinates for the center of the circle, or are the coordinates. So what I like to remember is it's just going to be the opposite of whatever you see in the equation format. And what I mean by that is like where h is, right? If you see a -5, it's just going to be the opposite for h, so it's going to be +5. So already I know it's going to be A, but let's just keep on explaining for the k part. So then where k is supposed to be right over here, I see there's a -7, so I'm going to do the opposite of that and get +7. So yes, the answer is A. So pause to read 5 if you haven't already. So remember, I've rewritten the format for the equation of a circle right up there where h comma k is the center of your circle. So that means that our h has to be 0 and our k is -4. But in order to have the complete equation, we also need to figure out what r is, the radius. We can do that using what they have given us for the area, which is 36 pi. I know that the area of the circle is equal to pi r squared, so I can just, instead of saying A, plug in 36 pi for the area and solve for r, the radius. So I'm going to do that. I can cross out a pi on each side because it cancels out. And now I know that r squared is equal to 36. Remember, I need r to be squared anyway, so it's equal to what I just got there, 36. So now I have to see what matches that in the answer choices. So the correct answer that matches would be B, because remember, if you do minus a minus, that's a plus. So it would be y minus -4, which just turns into y plus 4 squared. Okay, pause to read 6 if you haven't already. So I rewrote the equation for a circle up here for reference. Now you'll notice that the equation we've been given does not look like that. So what we need to do is make it look like the equation we're used to. That way we can easily identify what the center of the circle is and what the radius is. And the way we're going to do that is by completing the square. But first, I'm going to divide this whole equation by 7. That way I can get rid of the coefficients in front of x squared and y squared. I get this when I divide by 7, And now I'm going to rewrite it to complete the square with the x's together and the y's together. And this is what that would look like, where the blanks are going to be what I'm going to be putting in to complete the square. So to complete the square for the x portion right over here, I'm going to just focus on the x portion. And to figure out what goes in that blank, I have to divide the coefficient in front of x, which is -4, by 2, and then square it. So -4 divided by 2 is -2, and then when I square it, I get +4. So that's what goes in that blank, and I also need to put it in a blank space on the other side to balance the equation. Because I can't just say that the left goes up by 4 and the right stays the same. It's not going to be equal to each other anymore. Whatever I increase the left by, I have to also increase the right by. So now I'm going to figure out what goes in the blank by the y's. So to do that, I'm going to look at what's being multiplied by y, which is 2. Again, divide it by 2 and square it. So 2 divided by 2 is 1, square it and you get 1. So I also added that in on the blank on the other side to balance the equation. Now I just need to factor on the left-hand side and combine my like terms on the right-hand side so that I get something that looks like the typical equation of a circle. And when I do that, I get this. So when you're factoring, just look at like the x portion by itself first, and then I could say, oh, I know that to get back to this x squared minus 4x plus 4, I just have to do x minus 2 times x minus 2, which is the same thing as x minus 2 squared. And then you apply that same logic to the y portion, and then you just say 4 plus 4 plus 1 is equal to 9. So now I know that this is looking like the typical equation for a circle. I know that r squared matches up with 9, so what number squared gives me 9? That's 3, so the radius must be 3. And now I need to look for h comma k, so I'm going to look for h next to the x portion, and there's a -2 there. The opposite of that would be +2, so +2, so I already know it's going to be c, and I can confirm that because I look next to the y's and there's a +1. The opposite of that is -1, so that matches c. Okay, pause to read number 7 if you haven't already. So the first sentence is basically just giving you a fact that if you take the radius and the ratio of the radius to the area, that you would get this when you end up simplifying it, because you would just divide by r on each side, and that gives you this. So let's focus on kind of like the middle step right there to figure out what happens if we double the radius to the area. So I'm going to say I have 2r, and then in the area formula over here, instead of r, I'm going to also put 2r because I have double of the original radius. Now I just need to simplify. So I know that this is going to be equal to 4 pi r squared because 2r times 2r is 4r squared. So I rewrite it like that. And then I know, okay, well, what's going to be happening to the area? Well, the area originally was this, right? So what happened to the area? Well, it's multiplied by 4. So it would be d. Okay, pause to read number 8 if you haven't already. Okay, so I'm sorry for this poor drawing, but that is a pizza cut into 9 slices, and we want to find the perimeter of 1 slice of pizza. So basically we want to know the length of this arc, and then this line, and add all those up to get the perimeter of that 1 pizza slice. Now we know the area is equal to 49 pi, and the area of a circle is equal to pi r squared, so let's plug in 49 pi for a, the area. Now what I can do here is I can use that to now solve for the radius r, because you'll notice that this and this side of the pizza are going to be equal to the radius r. So all I would need to do is figure out what this guy is, that arc length, and then add that to r plus r to get the entire perimeter of that pizza slice. Now, since I know the pizza is cut into 9 equal slices, I know that that arc length is going to be 1/9 of the entire circumference of the circle. So essentially, if I do 1/9 times the circumference plus r, I get the answer to my question. So let's solve for r first. I can cancel out a pi on each side. And then I have r squared equals 49, so r must be 7. Now remember, circumference, the formula says that circumference is equal to 2 pi times the radius. So I can figure out circumference if I just plug in this 7 for the r right there. And that gives me the circumference is equal to 14 pi. So now I have r and I have c, the circumference. I can just plug it in to this original expression to figure out the answer to my question. And if I plug in, this is what I get. And now I just need to combine my like terms and multiply 14 pi by 1/9. And that gives me b as my final answer. Now for the next couple questions, I put like this little disclaimer there that you're going to see, you wouldn't see all of these. You would see like one of these is an example of a question you might get on the digital SAT exam. Like they don't put them in like groups of questions anymore. So just keep that in mind. It's just I wasn't going to format it like that just to save paper because like this is a pretty big image, and like, wasn't going to do that. So pause to read number 9 if you haven't already. So for this question, we want to find the slope of line n. Now, since line n is tangent to the circle, I know it essentially means what I've just drawn, that it like makes a right degree angle if we were to extend out like a line that represents the radius to that point A. So these are perpendicular lines, that dashed line and that straight line n, meaning that the slope of one is equal to the, if we want to find the slope of line n, it would be equal to the negative reciprocal slope of the dotted line. So let's figure out the slope of that dotted line and then take the negative reciprocal. We could figure out the slope of the dotted line by just plugging in the coordinates for point M and point A into the slope formula. This is the slope formula and how I've chosen to label my points. So when I plug that in, I get that the slope of that dashed line is going to be 3/4. So if I want the slope of the perpendicular line, line n, I need to flip that upside down and take the negative of it. So it would be -4/3 or b. Okay, pause for read number 10 if you haven't already. So I know from the previous problem that my slope for line n is -4/3, and if I'm using y equals mx plus b, I can just plug in -4/3 for the slope m. Now I need to figure out how to find b to have a complete equation. Well, I know that A is a point on line n, so I can use 3 as my x value and 5 as my y value, and I could plug that in to solve for b. So I do that, and now I just need to solve for b. So the 3's will cancel out, and now I just need to add 4 to each side to get b by itself. So b equals 9. So now I plug that in for b, but I notice the answer choices don't look exactly like my equation, so I need to manipulate my equation to look more like the answer choices. So I notice there's no fractions in the answer choices, so they probably multiplied by the denominator 3 all across the equation to get rid of that denominator. So let's do that first. So when I multiply everything by 3, I get this. Now I also see in the answer choices that x and y are on the same side, so I'm going to add 4x to each side to move it over next to the y. And when I do that, the answer is C. Okay, pause read number 11 if you haven't already. So in the previous problem, we figured out that line n has this equation right there. So to figure out if one of these points lies on line n, we need to plug in the point for x and y and see if this equation holds true. So let's start with A. So all I did was plug in -3 for x and 13 for y so far. So now I'm going to do the multiplication and addition to see if this is true. So when I multiply each of those parts, I get this. Now I'm going to add. And when I add, it does hold true. I do get 27 is equal to 27. That's true. So that means that that point must work on the line. So the answer is A. Okay, pause to read number 12 if you haven't already. So this is the information we've been given, and we want to solve for what the value of x is, what one possible value is. We also know that x must be an integer, and that it's in degrees. So if we know that x is in degrees, we're going to be using this arc length formula. It's kind of just intuitive that arc length is a fractional part of the entire circumference. So like this is the circumference formula, and then you're multiplying by the fractional portion of the circle that you're talking about, which would be x degrees out of 360 degrees. So now I just need to plug in my given values. I know arc length has to be between 3 and 4, and I know that the radius is 6. So if we're going to put it in an equation format, it's going to look like this. Now, what I would prefer is, and you could do it a different way, like you could solve for it equaling 3 and equaling 4 and then kind of like logistically see what x could be in between that. I think it's easier to visualize as an inequality statement, so that's what I'm going to do. So I'm saying it has to be within these values for arc length, essentially. So let's do 2 pi times 6, and that gives us 12 pi. And now I'm going to cross cancel the 12 with the 360, and that gives me this. Now I'm going to multiply each side by 30, and then divide each side by pi to get x by itself. And this is what I would get. So now what you're going to want to do is remember x is an integer value, so it has to be within these bounds. And you're going to want to plug in 90 divided by pi into your calculator to get like an estimate for what that is, and then do the same thing with 120 divided by pi on the other side. So I just rounded that to the nearest thousandth because you have like a decimal going on forever. And this is what I got when I rounded. Now remember, x has to be an integer, so it can't have like a decimal portion with it. So that means that x can be any number between and including 29 all the way up to 38. So like 29 and 38 work, and any of those whole numbers in between. Okay, so we're going to be using this diagram for the next couple questions. And there's a little typo up in the thing. I didn't mean 14 through 16. Like obviously this starts at 13. I'll fix that later. Not a huge deal right now. But pause to read number 13 if you haven't already. So we want to find the arc length here. So arc length is going to be equal to the fractional portion that we're talking about for the circle times the circumference. You can memorize the exact formulas if you want. I just find it easier to think logically about these things. So I'm talking about 60 degrees out of 360 as my fraction. And then I'm going to multiply by the circumference, which is just 2 pi r. And for r, I have 8. So this is what I get as my setup. So now I'm just going to do all the necessary multiplying and simplifying and figure out what my arc length is. So I know that the fraction simplifies to 1/6, and now I'm going to multiply 2 pi times 8 to get 16 pi. And now I'm going to cross cancel because I know 2 goes into 6 and it also goes into 16. So I have now 4 pi over 3. Or actually, sorry, take that back. I don't know why I got 4. 16 divided by 2 is 8, so it should be 8 pi over 3. So now in your calculator, you would do 8 times pi divided by 3. And when you do that, you get something like this that just keeps on going. And remember, the problem said round to the nearest hundredth. So this is the hundredths place, what we're rounding to. Let's look at our neighbor. Our neighbor is a 7, so we have to round up to 8.38. So that's what we get as our final answer. Okay, pause read number 14 if you haven't already. But it's asking for the arc measure in radians. So we know arc measure is equal to the central angle. Our central angle here is in degrees at 60 degrees. So arc measure is 60 degrees. We just need to now convert that to radians. So to convert from degrees to radians, we have to multiply by pi over 180. And we see that we can cross cancel because 60 goes into 60 once, it goes into 183 times. So that just gives us pi over 3, or A. Okay, pause read number 15 if you haven't already. So similar to the arc length logic of how I've been showing you guys to remember the formula, you can do this same thing with area, where you talk about, okay, I'm talking about this fraction of the circle times the area of the entire circle is represented by pi r squared. So let's look for what fraction of the circle we're referring to with our diagram. So the central degree is 60 degrees, so we're talking about 60 degrees out of the total degrees in a circle, 360, so 60 over 360. So if I divide the top and the bottom by 60, I get that that's 1/6. So I'm talking about 1/6 of my circle's area, which the area of the whole circle is represented by pi r squared. So now I just need to know what r is, the radius, plug it in, and solve. So I see the radius is 8, so that's what I'll plug in for r. And now I just need to do 8 squared, that's 64, times pi is 64 pi. And I can cross cancel the 6 and the 64 with a 2, because 2 goes into both of those evenly. And now I just need to multiply across. And when I do that, I get 32 pi over 3. Now, remember, That's the area of this whole entire portion right here. Now, if I want just the scribbled region, I have to think, okay, I have to subtract out this triangle, the area of that triangle. So I have to think, okay, well, I know that this is 8. The radius is 8 and 8 right there. This is a 60 degrees. I know that this angle has to equal this angle if those corresponding sides are equal. And the only way for that to work, since a triangle needs to add up to 180 degrees, would be for this angle to also be 60 and this angle to also be 60, which means that this side length has to also be 8, just FYI. So I have to find the area of an equilateral triangle. I mean, you could draw like a little dotted line here and have that be like the height, and then this will be the base if you want. But there's also a formula specifically for equilateral triangle, like finding the area of an equilateral triangle. And this is the formula where S represents the side length, which is 8 for that triangle. So I'm just going to use that one because it's faster. So I plug in 8 for S, and now I just need to solve and simplify. So 8 squared is 64. Now I just need to cross cancel the 4 and the 64. And then I would get 16 times root 3, 16 root 3 as the area of that triangle. So that's what I have to subtract out. I have to subtract 16 root 3 from this. Now you'll notice this doesn't look like anything I have right there. That's okay. That doesn't mean I did it wrong. It just means I have to manipulate the equation to look like one of these. So I see that B, C, and D factor out of 1/3, so I'm going to try doing that. And this is what I get when I do that, which is answer choice D. Okay, pause to read number 16 if you haven't already. Okay, for number 16, I'm now realizing I should have clarified that M is the midpoint. I forgot to write that like extra set of information. So just pretend I did. I'll add that into the next addition. So if this is the midpoint, then, and this is the diameter, I can use the midpoint formula to figure out what that other endpoint is. So the midpoint formula essentially says that like the coordinates for the midpoint, like the x comma y, have to equal you adding up the x's for the endpoints and dividing by 2 and doing the same thing for the y. So that's what I've written out here. Now I'm going to start with my x coordinate, -1, and set it equal to 3 plus x over 2. So I can now use this to solve for x, which is the x coordinate of the point I'm trying to find. So I'm going to multiply each side by 2. And then I'm going to subtract 3 from each side to get x by itself. So just from that, I know the answer is going to be D. If you want to keep solving, just to confirm it, you could and say that 5 plus y over 2 has to equal to the 2 right over here. So this has to equal that if you wanted to kind of prove that to yourself, but you don't need to. It's D. Okay, so pause to read 17 if you haven't already. So this is essentially the information we've been given, and I just called the arc length CD over here x and BC y, and then plugged in the other given information and the formula for circumference. So the question's asking us to figure out what is equal to 2 times the arc length of BC, or in this case, we could rewrite it as 2 times y. Now we also know that AC and BD are diameters, and based off of that information, I know that 8/3 x plus x right here, those are the arcs that correspond to making up half of the circle, right? So if I add those up, those arc lengths up, I'm going to also get half of the circumference. I also see that these angles right here have to be equal to each other. Therefore, since those are both central angles that are equal to each other, then that means that this has to equal this. The corresponding arc lengths have to be equal. 8/3 x is equal to y. So I could also say that y is equal to 8/3 x. So if I replace y with that, I'm really being asked by the question to find 2 times 8/3 x. So technically, I don't even need the circumference formula, I don't think. I can just say, okay, half of that circumference, or half of when I multiply 121 pi, has to equal the sum of these guys right here. 8/3 x plus x, which is the same thing as 3 over 3x. So if I add those up, numerator would be 11x, and then the denominator would be 3. So that has to be equal to 11/3 x. So now I'm going to multiply by a half right on this side. So I get 121 pi over 2 is equal to 11/3 x right over there. So now I'm going to divide by 11/3 on each side to get x by itself. And that way I can figure out what x is and then plug it in right over here. Now dividing by 11/3 is the same thing by multiplying by the reciprocal, 3/11. So this is what I get. I can easily cross cancel. 11 goes into 11 one time. It goes into 121 11 times. So it's 11 pi times 3 on top and then 2 times 1 on the bottom. So I get that for x. Now I just need to plug in that value for x right here to answer my question. So this is what I get, and now I just need to multiply and simplify if needed. I see that I can already cross cancel a 3 right here. 3 goes into 3 one time. It goes into 33 11 times, so I'm left with 11 pi there. Also, these 2's cross cancel, so I can just say, oh, I have 8 times 11 pi, which is 88 pi. So the answer would be D. Okay, pause for number 18 if you haven't already. So this is the information we've been given, and we're trying to solve for the radius. Now, if I know that AC is the diameter, I know that this arc length right here is representing half the circle or half of the circumference when I'm talking about arc length right there. So I know that that arc length is equal to half the circumference. So I'm representing that with this equation right here, and then I can replace circumference with the formula that I'm used to, which is circumference is equal to 2 pi r. So instead of c, I could put 2 pi r. So that's exactly what I did here. Now I'm going to cross cancel the 2's right here. And then I'm going to say, oh, a pi cancels out with a pi on this side. So now I'm just having 1 times r is r. And then I'm just left with 6 over here. So the radius is 6. Okay, pause to read 19 if you haven't already. So there's 2 formulas for circumference. You could say it's equal to 2 pi r or pi times the diameter. Since we're solving for diameter, in this case, it would be better for me to use circumference is equal to pi times the diameter. So that's what I'm going to do. So I know the circumference is equal to 144 pi, so I'm going to replace c, the circumference, with 144 pi. And now I'm going to cancel out a pi on each side, and that gives me that the diameter is equal to just 144. So that's your answer.